Previously, we covered the core foundations. Now in part 3, we tackle what you actually see when watching a rocket launch. Part 3. The mysterious jellyfish clouds that follow separation. In our previous episode, we explored why rocket launches sometimes create those spectacular sky spirals. Today we're tackling something equally mesmerizing, but far more mysterious. What are those ghostly, jellyfish-like clouds that suddenly bloom across the sky after a rocket separates its stages? They appear for minutes, pulsing and expanding like living creatures made of light. This is part 3 of what you actually see when watching a rocket launch. And today, we're diving into the physics behind these ethereal separation clouds. When a rocket reaches the upper atmosphere, typically some 80 to 150 kilometers up, the air is so thin, it's practically a vacuum. Up here, the normal rules of how gases behave start breaking down. During stage separation, several things happen simultaneously. The rocket vents residual fuel and oxidizer from its tanks. Explosive bolts fire to release components. And crucially, pressurized gases that have been contained within the rocket structure suddenly escape into this near-vacuum environment. In normal atmospheric pressure, escaping gas disperses relatively quickly. But in the vacuum of space, these gases expand explosively outward, with virtually nothing to stop them. The result is a rapidly growing sphere of gas that can span dozens of kilometers within minutes. The jellyfish shape comes from the interaction between the expanding gas and the rocket's continued forward motion. As the gas cloud expands uniformly in all directions, the rocket continues racing upward through the center, creating that distinctive dome or umbrella appearance. Different separation events create slightly different cloud signatures. Booster separation typically produces the largest and most dramatic clouds because of the substantial amount of residual propellant involved. Payload-fairing separation creates smaller, often twin clouds, as the two fairing halves are jettisoned simultaneously in opposite directions. The most spectacular jellyfish clouds occur during twilight launches, roughly 30 minutes before sunrise or after sunset. This timing creates perfect viewing conditions. The sky appears dark from the ground, but the rocket and its gas cloud are high enough to still catch direct sunlight. The thin, expanding gases scatter this sunlight, making the entire cloud glow with an otherworldly luminescence. It's the same principle that makes noctilucent clouds visible, but happening in real time as we watch. Daytime launches produce identical gas clouds, but they're usually invisible against the bright sky. Night launches can create visible clouds, if the rocket carries its own illumination, but they lack that ethereal glow that makes twilight events so memorable. The clouds themselves are completely harmless, just very thin concentrations of gases dispersing into space. But they serve as a visible reminder of the immense energies involved in spaceflight and the unique physics of the near-space environment. What makes these phenomena particularly fascinating is their scale. A cloud that appears modest from the ground might actually be larger than Greater London. The gases eventually disperse completely, but for those few minutes, you're watching a human-made aurora of sorts. Industrial activity made beautiful by the physics of space. Understanding these jellyfish clouds helps you read the story of a launch as it unfolds. Each glowing dome marks a critical moment in the rocket's journey, a visible sign that another piece of hardware has done its job and been left behind. Next episode, Part 4, explores the next key question in our series on what you actually see during rocket launches. If you found this useful for understanding what happens during those spectacular launch moments, consider subscribing. We break down the science behind space exploration without the unnecessary drama. That is part 3 of what you actually see when watching a rocket launch. In part 4, we explore the next key question. Subscribe so you do not miss it.